Hey, welcome back to your favorite trigonometry class. We're going to take a look. We're going to continue on with these parametric equations and graph of the plane curves. Let's take a look here at this cosine x equals cosine of t and y equals 2 sine of t parametric equations. And just like those other ones, we're going to make a table of values for t. We're going to start out, notice our parameters here for t, 0 up to 2 pi. I'm going to pick some really nice points since I know I have cosine and sine, so I'm going to go with pi halves, since I know the cosine of pi halves is 1 and the sine of pi halves is 0 and so on. So pi halves, pi, 3 pi halves, and then 2 pi. And we know x is 4 cosine t. We know y is 2 sine of t. And that'll spit out our xy ordered pair. Alright, so let's start out. If t is 0, x equals 4 cosine of t. So x equals 4 cosine 0. We know the cosine of 0 is 1. 4 times 1 is 4. Now let's do it for y of t equals 2 sine of t. So y of 0 spits out 2 times the sine of 0. We know the sine of 0 is 0. 2 times 0 is 0. So y ends up being 0. So our first point is 4, 0. And then we'll continue on. Let's do that for pi halves. Well, we know cosine of pi, again, I'm plugging it in right here. So 4 times cosine of pi halves. We know cosine of pi halves is 0. 0 times that 4 in front is 0. And then we know, let's plug it in now to 2 sine of pi halves. We know that the sine of pi halves is 1. So we got 2 times 1 is 2. So we have the ordered pair 0, 2. And we'll continue on. Now we're going to plug it in. You know, for t being pi, maybe we'll write one more down here. X equals 4 cosine pi. We know that the cosine of pi is -1, so we get an x value of -4. And then we're plugging it into the 2 sine of t. Plug in the pi. We know the sine of pi is 0. 2 times 0 is 0, so we get a y value of 0. So we got the point -4, 0. Plug in 3 pi halves. I know the cosine of 3 pi halves is 0, 4, and then 0 times the 4 in front there is 0. I know the sine of 3 pi halves is -1, so we got 2 times -1, which is -2. So this is the point 0, -2. And finally, the cosine of 2 pi is 1. 1 times that 4 in front is 4. Sine of 2 pi is 0. 2 times 0 is 0. So we have 4, 0. Let's go ahead and erase this so we can draw our curve here. Alright, let's put on 4, 0. We put on 0, 2. 0, or -4, 0. 0, -2, and then it's back to 4, 0. And I could put some more points on, you know, if I picked on more points. And what you see here, if I did pick some more t values, is, I didn't draw it the greatest, but anyways, what we have, if you notice, is we got an ellipse, right? We got an ellipse that's centered at 0, 0, centered at 0, 0. Notice our A here is 4 over to the vertex. Notice our B value is 2. This thing is elongated horizontally. So we've got this equation, x minus h squared over a squared plus y minus k squared over b squared equals 1. Our hk is 0, 0, and our a is 4. So we got x minus 0 centered there. Our a is 4. K is 0, again centered at the origin. B is 2. So we got x squared over 16 plus y squared over 4 equals 1. This is our rectangular equation for this ellipse. And I didn't put the orientation. I started here at 4, 0, and I went around to 0, 2, and it kept going around counterclockwise, so I really should put the arrows on that. Alright, but that's the equation that you could also have. That's the rectangular equation for that parametric curve, which does show the orientation there. Alright, let's keep going on. There's a little better picture of it, by the way. Let's do this one now. How about 3 cosine t and 3 sine of t? Again, I'm going to pick 0, pi halves, pi, 3 pi halves, and 2 pi. And let's throw in 0. So we're plugging it in right here. Cosine of 0 is 1. 3 times 1 is 3. Now I'm plugging it into the y value. Sine of 0 is 0. 0 times 3 is 0. So we have the point 3, 0. Now let's plug in pi halves. Let's throw it into 3 cosine t. So we got 3 times the cosine of pi halves. I know the cosine of pi halves is 1. 3 times that 1 is... the cosine of pi halves is 0. 3 times 0 is 0. Sorry about that. Now I'm plugging it into this one, y equals 3 sine of pi halves. I know the sine of pi halves is 1. 3 times 1 is 3. 0, 3. Now let's plug it into pi. 3 times the cosine of pi. Again, I'm throwing it into this x value here for t being pi. Cosine of pi is negative 1. 3 times negative 1, negative 3. Sine of pi is 0. 3 times 0 is 0. So we got negative 3, 0. Cosine 3 pi halves is 0. So we get 3 times 0 is 0. Sine of 3 pi halves is negative 1. 3 times negative 1, negative 3. So we get 0, negative 3. And then finally, cosine of 2 pi is 1. 3 times 1 is 3. Sine of 2 pi is 0. 3 times 0 is 0. So we got 3, 0. For that last one. Alright, let's go ahead and plot this thing. So we're starting out when t is 0, spits out an xy of 3, 0. So it starts out right there. And then it goes to 0, 3. Then it goes to negative 3, 0. And then it goes to 0, negative 3. Then it goes back to 3, 0. And of course, you could plug some more points in. You could kind of, for t if you wanted to, right? You get some more points on there. But soon enough, you see, hey, let's see if I connect these dots here. It's going counterclockwise orientation with these arrows. It's a circle, right? It's centered at 0, 0 again. That's our HK center for the rectangular equation. So here's the equation for a circle. X minus h squared plus y minus k squared equals r squared. And if you can see that our radius here is 3. So I got x minus 0 squared plus y minus 0 squared equals 3 squared. So x squared plus y squared equals 9. That's the rectangular equation for these parametric equations given above there. There's another picture of that. All right, let's finish off here with a few examples of just writing parametric equations for the curve given where y equals negative 3x plus 2 with the definition of x equals 2. So number one, what I'm going to start out with is I'm like, well, they give me that x equals t, sorry. And so, and we know that y equals negative 3x plus 2, and so by substitution, if x equals t, I'm going to plug that in there for x. So y equals negative 3t plus 2. So our parametric equations are x equals t and y equals negative 3t plus 2. Those are our parametric equations. Let's do another one here. Notice it's given us x equals t over 3, and so I'm going to use that x equals t over 3, number one, this definition, to, by substitution, I'm going to plug that in for x. So to solve for one of those variables for x, let's already solve for, x is in terms of t there. So by substitution, I can plug that in for x right there. So 6t over 3, in other words, 2t minus 4. 2t minus 4. So our parametric equations are x equals t over 3 and y equals 2t minus 4. How about this last one? We've got, or example A, before we get into a different type of example. X equals, this time we got negative 5t squared. We're going to throw that into the y equals, y being defined in terms of x, y equals 7 minus 2x. Here's what x is equal to, so by substitution, let's throw that in. So y equals 10t squared plus 7 is one of our parametric equations, and x equals negative 5t squared. And you can also write these y of t equals 10t squared plus 7 and x of t, because again x is x and y are both defined in terms of a third variable t. Oops, that's a squared right there. Here's our parametric equations. All right, this last one's just asking us find a parametric equation that defines the curve starting at 4, 0. Notice we've got the line there, and it ends at 7, 6, as shown in the figure. And let the parameter start at 0 and end at 6. So number one, what I would do here is I'm going to find a rectangular equation for the curve, and since this curve's a line segment, I'm going to try and write this as a line, y equals mx plus b, right? So I'm going to start out, number one, notice it's a line, so I want to get it in this form, y equals mx plus b form, right? Or I'm going to find the equation for that line first and then put it in the parametric equation from that, okay? Well, we need to know a slope. We're going to have to write the equation for that. So let's start out, find the slope here. y2 minus y1 over x2 minus x1, given the points 4, 0 and 7, 6. Right? Here's my x1, y1. Here's my x2, y2. Let's go ahead and plug that in, find our slope here. We got 6 minus 0 over 7 minus 4. So our slope is 6 over 3, which is 2. Okay, number one. Now number two, let's write the equation. So we have a point, we have a slope. Let's use point slope form. So y minus y1 equals mx minus x1. So we have this slope, have this point, y minus the y1, which is 0. Again, I'm using that point 4 as comma 0, equals a slope of 2, x minus 4. So y equals, distribute that, 2x minus 8. Okay, we've got the equation for that line. Next, we need to create the parametric equations. Okay, Now notice that the t starts from 0 and ends at 6, and if you notice, the y also increases from 0 and goes up to a y being 6. So I can make the assumption that y is the same as t, that interval is the same. Y is equal to t. Now that I know that, by substitution, I have this y equals 2x minus 8, and notice what's y equal to? Y is equal to t. So t equals 2x minus 8. And now I'm going to solve this for x. So let me add 8. So I have t plus 8 equals 2x. Let me divide everything by 2. So x equals t over 2, or 1/2 t, plus 4. X equals t over 2 plus 4. That's one of my parametric equations. And we also know that y equals t. These are my two parametric equations for this line. All right? So again, start out, find the equation of the line, and then use your parameters there. In this case, with y being equal to t to create those parametric equations. All right, thanks so much for listening. We'll see you guys next time.